We'll be comparing some pandas code directly to some live coded SQL code. And we'll see what are the differences mechanically, but more importantly than the mechanics, what is the conceptual thinking and the approaches that you need to take when coding in SQL, and what are the conceptual approaches you need to take in pandas? So, I am populating our database with two data sets here, two tables, and you can see them. One is a data set with some dates. We have two categorical variables and then two continuous variables. And our other table is kind of a wide format, right? Just 4 signals titled A, B, C, and D. So we'll be using these in our examples as we move through. How do we group by and aggregate on existing columns? So columns that are already part of the data set. Well, Pandas has this fairly straightforward. You just group by that column, and then you call the aggregation that you want. Nice and simple. If you want to, say, group by multiple columns, you can do that just by simply adding another column. It's super simple. And so if I were to run this operation here, you can see that I can now group by both the category and the facet, and I can get the means of all the values. It's even flexible enough to allow me to perform different aggregations on different columns while still maintaining the group by. And lastly, we can assign a new column, right, a new name to our aggregated value. So in this case, I'm taking the mean of value 1, and then I'm just renaming that to average value. So, James, can you perform this same type of aggregation, aggregating by one column, by multiple columns, and performing different computations on those value columns?
I seem to have been summoned. Thank you, Cameron. I think that anything you can do in Pandas, I can do in SQL. I can't say that anything you can do, I can do better, because the models are so different. And there's definitely going to be things that we'll discover cannot be done easily or may not even be possible to do without extraordinary contortions in SQL, and vice versa in Pandas. That said, Pandas is probably a little bit more flexible of a tool because, as you mentioned before, there are always these safety valves, these escape hatches that you can find with the tool. There's always a .apply or an iter rows that you can do to just make this work. But the challenge in front of me is to identify how to group by and aggregate on existing columns. And so I'll step through this. And in order to do this, why don't I share my screen? Behind me, you'll see my screen. I will, of course, hide in the corner here. And let's take a look. And I'm thinking about this through looking at this problem for the first time. And we have our data in this fashion. And so we want to aggregate this data by a particular single column. Well, that's pretty easy. We have the group by in SQL, and it works largely like the group by in Pandas. So if we say select star from data, group by, and then we group by, let's get the first rows, let's get the names of these columns, just so that we have something that we can see. Okay, there we go. So here we'll select from data, we'll group by, say, the category. If we do that, one of the things that SQL is going to ask us that we do is ensure that the expression that we have either is an aggregate function on each one of the tuple values, each one of the columns as it were, or is the unique column. So I'm going to have to put the unique column here, that is the category, and then I'm going to have to put the combination. And so if I want to do a mean on the value 2 or the value 1, I would just do mean value 1. That's pretty straightforward, except, I don't know, everything's named differently. It's AVG instead of mean. You know, I'm sorry. You know, this is the one thing. It's so irritating, right? One interesting thing is, are these values sorted? If this were Pandas, would these be sorted?
Yes, by default, those categories would be sorted.
Whereas in SQL, it doesn't sort them by default, and so I actually have to do an ordering of this data once I'm done. And one thing that we notice is the ordering is usually some kind of after the fact, if not display type of operation in SQL. The tuple space is really an unordered entity. It's just a bag of tuples that are floating around that have some fields associated with it. Whereas in Pandas, that columnar structure has a strict ordering to it. And so it kind of makes sense that the group by in Pandas would be like, oh, of course I'll keep it in some ordering. Whereas in SQL, they don't bother to do that. Now, Cameron, what's the next thing you want me to try beyond grouping by one single column?
All right. Beyond grouping by one single column, I am actually going to, again, ask you to group by one single column. However, in this case, I want you to group by dates, but I want you to group every single day. Our date column is on the fidelity of every 6 hours. That means we have 4 data points per day. If you want to work off that assumption, so be it. But I would rather see you work off the actual data to get the specific day, group by each of those days, and compute the mean for every single day.
Okay,
And if you're feeling up to it, we can also extend this example to group by month. In pandas, it's the simple switch of one keyword argument. What is it in SQL?
In SQL, I think this is still going to be a group by, because one of the things that we think about when we think about SQL is we think about the transformations that we're performing. And I think this is the way that you think about pandas as well. You think about the transformation of the index and how these different operations affect that index. In SQL, we think about how there's a transformation of the tuple, the set of the tuples that you're looking at. And so if I start with tuples, A, B, C, and D, a group by can be conceptualized as just some non-overlapping partitioning of this data. So I pick one individual column, I look at that one individual column, maybe perform a computation, like round it down to the nearest hour, the nearest day, and then I group them in some fashion and I create some aggregate on them. In SQL, the group by statement controls how many outputs you have. That is to say, if you have 10 input rows or 10 input tuples in SQL, and you group by, and there are 3 groups, 3 distinct groups, you will have 3 rows, 3 tuples in your result. Whereas in pandas, as I expect we're going to see soon, the group by can sometimes return a differently shaped object than what comes in. But with that said, let's do a select from our data and just see, okay, and so we want to group by the date, and we want to group by the date every day. That's not too hard. We do maybe run into the oddities of the SQL, naming and functions and syntax, because things which are really, they look like function, they look really mechanical, and we just understand, like, a grouper object in pandas. In SQL, this, I don't know if you're going to like, but what we're going to do is we're going to say a group by extract. Okay, let's see if I remember how to do this. We have to extract, and this is a function that takes a special keyword, extract day, from our date, and let's see if that does it. And then here, we need the extracted day from the date. There we go, and that gives us our day. And what you want is, that's the day of the month, right? So what you actually want to do is you want the
Group by year, day, month, or year, month, day.
Okay, so you want me to round this thing down, right? So you want to extract the, I can do that. I think what you want me to do is you want me to truncate this. So you're going to group by a date truncation, and you're going to have me truncate it on the day. And here, don't ask me why the syntax is different. But it is. SQL is the way it is.
Sometimes sometimes not.
Yeah, there we go. So we rounded that down. That's great. So that gives us the day. And then here you wanted the mean of the values, right? So we just need our average of the value 1. And then for the month portion, this I don't know off the top of my head, but I suspect we might just be able to do a truncation on this month portion here. I just don't know all the possible keywords. Okay, that seemed to work.
That looks
and of course,
like
if we want to order it, we can order it.
Yeah.
I'll show you one more thing. Because SQL is not from this kind of programming language perspective, we end up seeing this kind of repetition. Whereas in pandas, you would just pre-compute that, assign it to a variable, or you use a pipe or some mechanism like that. Whereas in SQL, in the absence of variables, what we might have to use is something like this. We might say select this as the month, and then all of the remaining columns from our data. Do that in either a subquery or a common table expression. So this is we'll call this our data underscore as this. So we know we're going to have to compute that anyway, maybe. And then we would do the same thing, and we'd have slightly nicer looking code like this. However, unlike, and that's right, and this is from data underscore. And the downside of this is, as we discussed previously, the common table expression is an optimization barrier. Unlike in pandas where you have step 1, step 2, step 3, and you look at those steps and you're like, well, step 1 takes such and such time, step 2 takes such and such time, step 3 takes such and such time. The total time is the sum of those. In SQL, the query engine is very intelligent, and it's going to do things to rearrange your queries or to change them in some fashion. Historically, the common table expression was an optimization barrier, so it would first pre-compute this and then do these options, then do the rest here. I don't think that's going to make a huge difference, but where syntactically in pandas we have a fairly close correspondence to how much work we're doing to what we wrote on the screen, that's not as clear in SQL. And I can imagine that there may be circumstances in which if I write this as a subquery instead of a common table expression, you may see different performance because your SQL query engine can merge or do predicate push down or something. Like if there were a predicate here, pick everything that's month 2, that would be pushed down into this query to make this query faster, but it wouldn't be the case here. Whereas in pandas, that would be immediately obvious when you do the locks and the ilocks and subset the data. So there you go. Let me get this working, and this would be as, like, you have to do something like that.
It's interesting. If that's predicate, without the predicate pushdown, would SQL have to do 2 scans through the entire database in order to, or the entire table, I should say, in order to compute that?
In this case, we can actually do an explain analyze. It'll take us more time than we have to really go through what the result of this is, but it's not unusual when you see some of these subquery things that it looks like it's just doing one single sequential scan on the data. So it looks like this is basically the identical operation to what I did before, just written slightly differently. Whereas in pandas, this would be 2 steps that are executed as 2 steps. But what more do you think you want to try doing in SQL versus pandas?
All right. So let's see here. Grouping by external data, right? So something that doesn't exist as part of our column, maybe it exists as part of another table, but in this example, it doesn't. So in this example, I am generating just a bunch of random 0, 1s, and 2s to represent 3 groups, and it has the same size as my table. However, I am not adding this to my column. I am instead simply giving it to the group by, and the group by is smart enough to figure out it goes and computes the slices that it needs to perform on the data frame itself, and it doesn't need those random groups necessarily. It does store them, however, in the output. You'll notice that my output is labeled 0, 1, 2, and if I were to change this to rng.choice A, B, and C, my index of my output would be A, B, and C. So, James, can you perform a group by operation on data that's not part of the table in SQL?
Yes, and also no. This is tricky. First, because pandas exists within your execution environment, it's not some remote computation that you're performing, it's a local computation. You can work on any arbitrary data you got, right? If it's in that same environment, pull it in and go for it. Whereas with SQL, if you think about it, you're constructing the query, and then you're sending it off remotely for somebody else to compute, which means I need that external data to be available in the execution environment at the SQL side. But I kind of get the point. You'd either create a supplementary table or something like that, or you'd have it hard-coded as part of your query. In this case, what I would do, and these were just random values, I believe, so I would do something like this. We would take a look at how we can construct this data and we join against it, because fundamentally in SQL, the group by must operate on some computation, group by something. This thing has to be a function of the tuples that you have. And it can be a function of multiple fields of the tuple. Like I think you had value 1 and value 2, so let's try doing value 1 plus value 2. You can do this. You can do this on these, and I think that, let me just do that and show how many rows. So it comes up with the number of rows. I'd have to actually do a little bit more contortions to get this thing to work. But you can see you can group on things within one tuple. Fine. You can't group on anything else but the data that's inside that tuple. So what you do in SQL is you bring the data into the tuple. And the way you bring that data into the tuple is via the join. And so what I would do is I'll first generate this data. So let's see if I can do that. Let me think how I'm going to do this. I'm going to first generate, so I'll select random. And I need to generate one of these per element that you have in the other database. So I can do this with the select statement. I can say select random from data. And here, this will give me one random number per data element that you have. Now, you wanted a random choice. And I don't know off the top of my head how you do a random choice other than a manipulation of the random itself. I think you can do random between. So that might be close enough to what you have. And I don't know if this is, I don't know, random between. Well, we'll just do some rounding here. This is a random number, so we'll do something like this. So we'll just do, round this thing, and then times 3 divided by 3 or some nonsense like that. So we get some value here, and then we get the 0, 1, 2, or 3, or times 2, and that gives you that. And what you could do, see, this is cheating because I can group by that expression. But you're suggesting that it already exists somewhere. So what I'm going to do is I'm going to select this into a temporary table. And I'll call this is my category or the facets or the grouping. So let's see if we get that working. OK. Select into that. Here, I'll say insert into or create temporary table grouping. And I need a similar key. So I'll probably have to do something like this, where this is the identifier, and this is the grouping, which is some integer, like this. And then I'll insert into this thing, selecting the identifier and that. That way I can match them up. And so here we're almost there. And OK, insert into table, or insert into grouping. There we go. And then I can join them. So this is getting closer. You'd have to pull the data into the database and then do a join. So you're going to select, and because I have the ID column, let me remember what you called your ID column. Hopefully if you just called it ID, then that makes, then I could do a natural join. So that makes my life a little bit easier. So select star from data, natural inner join grouping. So that gives me access to the grouping. And then I can say group by grouping. And I think this would be grouping dot G, I'll call it G because I don't know if I want to type anything more than that. And then I'll show you what the G is, and we can do some sort of aggregate function. So again, say mean of value 1. And let's see, this should be grouping.g, and this should be data.this. And here, I'm sure, well, in SQL's defense, why is it .curt instead of kurtosis? Why are all these weird shortcuts in pandas? Sometimes there's conveniences and sometimes inconveniences. So there you go.
Someone decided somewhere. And what I really appreciate about these SQL examples you're walking us through is that SQL is so rigid that oftentimes the query just doesn't work until you actually get the syntax right. Whereas with something like pandas, you can squeak out something that doesn't work, but you'll get a result and you can figure out what's going on. Whereas SQL, all you got is the words that you're typing, and you have to be able to typo fix there.
I would offer a counterpoint, however, and here's my counterpoint. How easy is pandas to use if it's not 400 rows, but 400 billion rows?
Near impossible.
But let's see what we have next.
All right. Well, next, we're not going across rows anymore. I mentioned that pandas was flexible earlier. I want to see you go by the columns. So in this example that I've prepared, We start with our second table here, and we have our columns A, B, C, and D. What I'm doing is I'm remapping A and B to early, and I'm remapping C and D to late, and I'm performing an actual group by operation across these columns, such that A and B get summed together, C and D get summed together, and they come out as early and late columns. So you can see that here in my mapping of my dictionary, and this axis parameter of group by. I think this might be fairly tricky to be done in SQL. But I'm curious to see what you can think of, or if it can't be easily done at all.
Group by columns. Well, if we think about this, isn't that just a group by rows after transposing the data? Here's the thing.
It very much is.
In Postgres, you can actually do pivot tables and these kind of transpositions, but I'll show you just very quickly some of the syntax for it, and we'll stop before we even get too far. It looks something like this. Select star from crosstab, and then you give it the string text for the SQL that it needs to run in order to do the cross tabulation. Clearly, this is something that is Postgres specific. This is something that's procedural, that's happening behind the scenes. This is not part of the core SQL ideology. And fundamentally, if we take a giant step back and we think about it, what on earth does it mean to transpose two-dimensional NumPy data? Well, it just means to turn your head to the side. What on earth does it mean to transpose pandas data? Well, I guess that means that you use the index lookup as the column lookup and the column lookup for the index lookup. But if the data is heterogeneous, that's kind of weird. What does it mean to transpose a tuple that has no natural ordering? Just a bunch of objects floating around that have fields associated with them. You take all the common, I don't know, it has no meaning. It has no conceptual meaning. You end up with one tuple per column, and I guess mechanically you can show the meaning, but conceptually, these aren't geometric structures like a two-dimensional NumPy and D array or a collection of one-dimensional like indexed pandas series or pandas data frame. And as a consequence, some things like transpositions are just not really meaningful in SQL. You can definitely do all of these group bys down the rows of an SQL table, but to do them across the columns, whereas pandas doesn't privilege operations across the columns, SQL says, look, I can give you an operation across the columns. It looks like this. Select A plus B plus C plus D from signal. That's about the most I can do. I can't look at more than one tuple at a time. I can't really transpose this thing. It's not particularly meaningful. And I don't believe there is a way without extraordinary contortions for me to transpose. Now, of course, Postgres is a tool that people use for their everyday lives, and there's always some escape hatch, there's always some safety valve, there's always some way to make this work. You could write a Postgres extension, there's all of that. But fundamentally, SQL isn't really defined in these terms, in this term of, you have some dimensional data and you can arbitrarily transpose that data.
Yep. And I think this brings up a very important point of why we have database administrators in the first place, right? When we're storing these data, if they're stored in a very wide format, probably not the best for our SQL, or probably not the best for future-proofing what we want to do. So that's why we had someone's job to really think through these types of problems and making sure that we can run efficient SQL queries on data that we have.